Subnetting. So we know that the classes of a network IP address, this is called the classful address, meaning that this is something we've learned already. Class A, B, and C have the first octet for class A identifies the network portion, and then the last three identify the host portion. For class B, it's the first two octets. For class C, it's the first three octets. Okay? This makes sense, right?
Mm-hmm.
This is what we've learned so far. Mm-hmm. Now, when we get into subnetting, subnetting is where we're going to take bits away from the host portion. So we know a typical class C address has the first three octets are reserved for the network. They're identifying the network number. Okay, that's what we see here typically when we see a 192.168.10 network. And the last 8 bits are reserved for the host. Well, if we borrow or steal bits away from the host portion and we turn them into subnetting bits, then what we've done is we've increased our subnets. So in this example, we are borrowing 3 bits or stealing 3 bits away from the host portion. So since we're stealing those 3 bits, 2 to the power of 3 equals 8 minus 2, because we can't use the first and last subnet, that gives us 6 subnets. And we'll go over this concept here shortly. Binary. Bits are powers of 2, right? Are base 2. So what we do is we have our 3 bits that we're borrowing. That creates 8 networks. 2 times 2. So if I have 2 to the power of 3, that's equal to 2 times 2 times 2. Whoops. Times 2. So 2 times 2 is 4, times 2 is 8. So we have 8 total subnets that we are creating inside of the 192.168.10 network. And we're going to go over these examples. I just want you to start seeing the bits and kind of understand some of this terminology that we're throwing out here. Okay, so down here, if I borrow, this is a class B. The class B, we know, has the first 2 octets are all reserved for the network portion. So when we steal bits, we steal 5 bits in this example. That's 2 to the power of 5, which is 32. 2 times 2 times 2 times 2 times 2 is 32. And the reason why we're subtracting 2 here, as I'll get into a little later, is that we can't use the very first subnet that's created, and we can't use the very last subnet that's created.
So it's kind of like the 1 and 255.
0 and 255.
So
Yep. Because and that is the exact reason why we can't use that first subnet, because it contains the original network ID.
Okay.
And the very last subnet contains the original network broadcast ID. So that's why we can't use the first and last. That's why the rule of subtracting 2. And of course, every rule we're going to break, because, yeah, okay. But we'll do that later, okay? Let's understand this basic concept here. Wes has a question.
Oh, no, I didn't.
Okay. Terry.
Did you say this is on a PowerPoint and we have access to it all?
This is a PowerPoint that I'm recording right now, and I'll make available to
I
you.
have a question.
Yep.
Is that an arbitrary number? You can take as many as you want?
Yeah, you can take as many as you want. There's a rule here, and we're going to see if we steal too many bits, there's not going to be anything left over for the hosts. So we're going to take a look at what happens there. Okay? But for now, just understand that when I steal bits, so could I steal 5 bits up here? Yeah, I can steal 5 bits up here, and I'd be creating 32 subnets, but how many bits are going to be left over for the hosts?
Yeah, but how do we know we can
Only
steal
3 are going to be left over for the hosts, and that's not too many hosts per network. Terry, you had a question?
Yeah, I was just saying, how do we know we can steal 5
How do we know? We're going to go into that here in a second. But what I want you to see here is what we're doing when we're subnetting is we're just stealing bits. Okay? We're just stealing bits. Okay.
So we're just taking bits from the host to increase the number of, is it like you're increasing the number of networks, kind of?
Yes, because let's make the assumption, and this might help clear up. Let's make the assumption that we were given the address 192.168.10. we can't change that network. That's the network. We have to stay within that boundary. So in other words, they go, here you go, here's one network. But then you're going to go, wait a minute, I need more than one network. I need at least 4 networks to separate my computers into 4 networks for security reasons or for whatever else that we may be doing. So because of that restriction, we're going to go, well, we can't change the first 3 octets of this Class C network that was assigned to us. So what we're going to do is we're going to subnet that into smaller little networks that, of course, have fewer host bits available per network.
So you wouldn't do this necessarily unless you were restricted to the number of networks.
Exactly, yeah. And the fact that this is a Class C, 192.168.10, we can just go, well, da-dee-da-dee-you, I'm going to use 192.168.11, because that's a private IP network, and that's a whole nother network, and away we go. But in this case, the 147.10, that is a Class B, which means that is a public address that's been reserved for my company. I'm an ISP, and I operate in 20 different markets, which means I need at least 20 different networks, because I want to separate my markets into 20 different locations, 20 different networks, because I'm an ISP, and I'm going to give out my services through my ISP service. But this is the Class B network that I was assigned, and that I'm paying for. Getting multiple Class B networks is very expensive. So now I have to take this one network and split it up into smaller networks or subnets. But the number of hosts per is going to be a lot smaller. Let's see if we can figure this one out. How many host bits do I have? 8 here in this Class B, and 8, 9, 10, 11. 2 to the power of 11, that's how many hosts per network I will have.
So basically, my home computer is a subnet of my ISP?
Yes, your ISP more than likely has been assigned probably a Class A that's been subnetted down into smaller subnets. And how do you tell? By looking at the Subnet Mask.
And your ISP buys this class?
The ISP will buy this class, or even smaller, if it's a smaller ISP, will be given a subnet. They go, here's your subnet.
Who else would have to buy their network?
What?
Who else would have to buy their class?
Who else would have to buy their network?
Yeah, but I mean...
anyone that wants a public access on the internet.
So that would mean that, like, Charter is selling subnets to other people.
Yes.
Who you might buy one from.
Yes. So if my company needs access to the internet, and we use the internet to connect our offices together, I'm going to purchase, and I'm on Charter is my ISP for all 3 towns that I may exist in. I'm going to purchase from Charter a subnet, and out of that subnet, I'm going to create even smaller subnets, so I can now route between my locations. And we'll get into the mechanics of this, and we'll give lots of examples, but that's kind of the basics examples we'll look at. And for Class A, look at the Class A, we borrowed 8, 9, 10, 11, 12 bits. So we can steal as many bits away from the host portion, but we got to leave some for the host. And we'll get into the details of this later. So we're borrowing bits. So this gets us into examples and reasons. Why? Flexible addressing. Okay, it allows us to create small LANs out of one network space. It allows us to organize and keep workstations within their own broadcast domains. The broadcast containment. When I send a broadcast message, every computer has to listen to that broadcast message. Computers are broadcasting crap on the network all the time, and they do that for you, to make your life simple. So you can go to your network neighborhood or network places and see all the computers that exist, see all the printers that are out there. Okay, so we want to contain that. Too many of computers are going to be broadcasting so much that it's going to be slowing down our network bandwidth that's available. So we try to make smaller networks by reducing the broadcast domain, or reducing the how large, how many computers are going to be broadcasting. And then security. This provides security at layer 3, meaning that we can set rules that say if you're coming from this network, you're not allowed. Or if you want to access that network, you can, but only this IP address on that network. So you can set rules on how we go, and that's kind of what a firewall does.
So as you break into subnets, is that going through the same router but rechanneled, or is it each subnet has its individual router?
Each subnet, trying to make sure I answer this correctly, each subnet has its own router, because it needs its own router to route between the subnets, but that router can be one physical device.
Okay. It's
logically,
right.
It's multiple routers or multiple router
Physically, it's
interfaces,
one.
but it's
It
one.
could be
It
one.
could be one physical router, or it could be multiple routers.
Right.
Yep. Okay. So that's why I want to make sure I could answer that correctly. But that was... Okay. So what we do is we establish a subnet mask. So when you see a subnet mask that's different than our typical 255.255.0.0, we see something strange like this, 255.255.240. Well, where the heck are they coming up with this 240? And that's where we take the number of bits that we have in the octet where bits are turned on and bits are turned off, and we add up the decimal value. So if we add up the bits that are turned on, that adds up to 240. Okay, you remember this?
Yeah.
If I have my 8 bits in an octet, the first position's worth 2, next one is 1, second one's worth 2, 4, 8, 16, 32,
64,
and 128. There you go. So 1, 2, 3, 4. Those bits are turned on.
Just add those up.
So you add up these and you get 240. So that's where we get the subnet mask. So this is telling me that my first 3 octets, I think I have too many ones. It's hard to talk and draw at the same time. So this tells me that I have 8, 16, 17, 18, 19, 20 bits turned on. So what would our CIDR notation that we learned last week be? A slash 20. The classless interdomain routing. So the slash 20. Where typically a class B, if this were a class B, would be a slash 16 CIDR notation, but the slash 20 tells me, oh, we're stealing 4 bits away from the host portion, which means that it's a slash 20 and that the subnet mask that I'm going to type into this workstation that's going to be part of this network is going to be 255.255.240.0. Okay, so how do we establish the subnet mask address? And this is a little review on how we did it, but we first have to identify how many networks we need. How many of these subnets do we need to create? So for this example, if I have a router, and this router has 3 networks attached to it. So I have 3 switches connected to 3 interfaces on a router. So I have essentially 3 networks. Network A, Network B, and Network C. So just based on the fact that we know we need at least 3 networks, how many bits do we need to borrow from the network mask? So let's say it's a class C, 192.160. Oh, let's go 192.161. So it's a public IP address. .1.0. So that is a first thing we do. We identify that is a what class? Class C, which tells us that the first 3 octets have been reserved for the classful original network, so we can't touch the first 3 octets. Which means we have 1, 2, 3, 4, 5, 6, 7, 8 bits available to us. that we can borrow from to create smaller networks for our 3 networks that we have here. So how many bits are we going to steal to make this network larger? We use the 2 to the power of, we need at least 3, so 2 to the power of 2 is 4, but we can't use the first and last, so that only gives us 2 usable that we can assign. So then we use 3, so we turn 1, 2, 3 bits are turned on. This is my new network range, or subnet range. Okay, all of these bits turned on here.
That would give you 6 usable.
2 to the power of 3 equals 8. I'm going to be creating 8 networks. And I can't use the first and last, so it gives me 6 usable. That is correct. Yep, you're working your way through that. So to get the subnet mask for this network, or for all of these subnetworks that I'm going to be creating, I count these bits on this last octet. So my subnet mask is going to be 255.255.255.128 plus 64 plus 32. And if you look at the little manual subnet calculator, you can see when I have just 3 bits turned on,
224.
that's 224. See how that little chart works?
Yes.
224. So that is my new subnet mask for all of the subnets that I'm going to be creating. Everyone see that? Okay, so we can derive the subnet mask from there. Let's take a look at the next slide here. Well, in this example, we have /25, which means that we have 255.255.255.128, meaning that only 1 bit was used. Does that example on the PowerPoint slide make sense? Okay. Terry.
And this is why I was wrong the other day when I assumed that you can tell the class by looking at the subnet mask.
That's right. This is exactly why. It's because looking at this, we don't even know what class it is. All we know that is that there's 25 bits total, but we're missing a part. We're missing, well, what is the IP address? So we can then from there determine what class it is. Because that could be a class A, B, or C with 25 bits used for the network mask. So now that we have the subnet mask, we now can identify the ranges of all of these networks that we are creating. In this example, we have these 8 networks that we're creating, and we, of course, start counting with 0. So subnet 0, subnet 1, subnet 2, 3, 4, 5, 6, 7. So that's 8 total networks. And we see the ranges here. So in this example, 192.168.1, we might as well use 168 here. .10. And this is our range. So how do we figure out the ranges of all of our networks? Let's come back here to the board and take a look. So we know we're creating 8 networks, or 8 subnets. Let's take a look at what's left over here. What's left over for the hosts? This is going to tell us our host range. So we know we're going to be creating 8 networks, but we need to figure out what is our host range. Where do they start and stop? That's where we take a look at the bits that are left over. 1, 2, 3, 4, 5. 2 to the power of 5 equals how many bits? 5 bits. 32. So it's going to be every 32 numbers is going to be a whole nother network. That's my range. So the very first address in this network, 192.168.10.0, is the very first address, correct? This we've learned already from the last few classes. This is where the bits are turned on and off in this range. This tells us our range for the hosts. Where is our host going to start and stop? And we need 32, so it's going to go 0 all the way through 31. And then the next range, so this is subnet 0. The next range is going to be 192.168.10. What's the next number? 32 through another 32 bits goes out to 63.
Why is that not matching up with what's
Well,
out
because-
there?
It is. You got to look at. It is matching up with this. Where's my laser? I just set it down.
You see this
Oh, yeah,
subnet
yeah,
one?
these are usable.
Do you see this first one here is
Yeah,
the
yeah, yeah.
network ID
Right,
and the
right.
broadcast ID.
Right. Yeah.
The range
Those
here
are
is the usable host ranges.
Yes, yeah.
Oh, because I
Yep.
did it.
So the first one here is 0 through 31. Here's 0. Here's
Right,
31.
right.
Next one, 32 through 63. Over here, that's the broadcast.
Yeah.
Wow.
Okay. Awesome when you see it, isn't it? So my usable IP addresses in this first subnet, subnet 1, my usable IP addresses are going to be 192.168.10.33 through 192.168.10.62 because 32 is identifying my subnet ID and this is my broadcast ID.
Piece of cake.
Yeah, can we quit?
Do you
Can
see
we-
it?
Can we quit now?
Yeah. Can we go home now?
Wes.
So, will they, all those networks then, that are subnetted, will they all be able to communicate internally to each other then? Or,
Let's draw some workstations up here to maybe answer your question. So, if we were to assign my workstations here, let's put 2 workstations here, and let's put 2 workstations here. Remember the router, I kind of didn't draw this correctly because the router is actually part of this network, correct? It's a member of that network, and this router is a member of this network. So the router is a part of the network. So we actually have how many hosts on this network C over here? 1, 2, 3. So I have 3 hosts over here. So let's use subnet 1 and let's assign an IP address. So let's assign it, the first IP address to the router. So 192.168.10. First usable address in subnet 1?
33.
3. Yep, 33. And I'm going to do a slash. What's my CIDR notation for this example? All the bits turned on in the first octet, second and third, that's 8 times 3 is 24, 25, 26, 27. So it's going to be a slash 27. Okay. So now this host, this first host right here, will get the next usable IP, 192.168.10.34. Over here, this host will get 192.168.10.35. What is the default gateway?
One above 33.
Yeah. So the gateway for this computer would be 192.168.10.33. It's going to be this device right here. That's how it's going to get out to the other networks. So now let's assign IP addresses over here on this network. So we need the next range, subnet range number 2. Do you see it up there? We have 192.168.10.64 is the network or the subnetwork ID.
65.
So the first usable is .65, so we're going to go 192.168.10.65/27, right? That identifies our subnet. First usable IP address here we can assign to this host. 192.168.10.66. 192.168.10.67. What is the gateway? 192.168.10.65. That's how it's going to get out to the other networks. So the subnet mask, if I were to write a subnet mask in here, it would be 255.255.255.224. And then my gateway is going to be the 192.168.10.65. Does anybody not see where I'm coming up with these numbers? Wes, so Your question is, well, all of these computers in network C will be able to talk to each other directly,
Yes.
They'll have to go through the.
but they'll have to go through the gateway
Uh-huh.
if the range, so if I communicate to, if I'm trying to communicate from this computer and I want to communicate to a 192.168.10.70 address, I'm going to be sending that through my router because that 70 IP address is outside of this range, isn't it?
Right.
So that tells it that it's in a different subnet. So does it know where that subnet is? It doesn't. All it knows is that, well, I don't know where it is, so I'm going to send it to the router, and hopefully the router knows where that 70 IP address is and which network that it may be in. So the router looks at the subnet mask that came through and says, oh, I know where the 64 network is, because this 70 address falls in the range of the 64 network, right?
Mm-hmm.
70 should be in here somewhere. So then the router is going to make that routing decision to route the packet to that interface and then down to the switch, and hopefully the 70 computer will be down here somewhere that will answer it. And if it's not, then the router says destination host unreachable.
Okay.
Yep. How we doing?
Good, we're good.
Yeah?
For today, don't ask us
Good for
again
today.
tomorrow.
So there's our manual subnet calculator, and we like to use this. This is very easily created. It took me several explanations of subnetting before I understood it. So don't take my one word, my one lecture on subnetting and assume that you're going to know how to subnet. And if you don't, you're dumb. Because I've had several people explain to me how to subnet, and I never got it until this one lady from Cisco drew this on a piece of paper for me. And this is what I show at all of my lectures about subnetting. It is seeing the bits. Everyone just tried to give me, and you'll see on the internet when you search for this, how to subnet. They're going to throw out all these rules. Well, just take 256 minus this number. Just take 256 minus 224, and that gets you the range of 32. And you just take 32, and that's your numbers, and you just take every 32, and blah, blah, blah. I'm like, whoa, that's too much math rules we got to follow. Where that's why I like to show the bits on where these numbers are coming from when we subnet. This table helps us with some of the math that we have to do. So we have 8 bits total. 1, 2, 3, 4, 5, 6, 7, 8 bits. When I have all the bits turned on, or there's a 1, it adds up to a decimal value of 255. When I add all of them up, all except 1, it adds up to 254. So I take the 255 minus the value of 1 over here, and it gives me 254. So you can just see quickly, 3 bits turned on, that should have the 224. Make sense?
Yeah.
Then we do the pop. What's that?
I was just thinking, I gotta remember to read left to right.
Yeah, it is left to right. It is left to right. Now the power is up here, to the power of, the only thing that doesn't really work out is to the power of 0 is actually 0. But anyway, so 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 32, 64, 2 to the power of 7 is 128. What's 2 to the power of 8? 256. You see how this keeps going? 2 to the power of 9 is 512.
1024.
Yeah. You see how that number keeps increasing when you see the powers of 2? So this is just a start for you. So this is really easy to create. If you can't remember these numbers, you can at least draw a chart real quick and put a bunch of ones, and just do some simple math to add things up and go, oh, okay, now you get the numbers. Here's the powers of 2, start with 0, or 2 to the power of.
2 to the power of 0 is 1.
Actually,
Is it? Is it actually 1? Oh, yeah, okay, this, okay.
Yeah.
I was thinking of that.
That
To the power of 0
yes,
is,
I had
okay.
to go. I had to Google it.
I think anything.
Thank you
power
for
zero
double
is-
checking
Sorry.
that, yes. What is that
Like,
math
I
you
know
learned
that-
in 4th grade or 5th grade?
Yeah.
And actually, it's math we just did over here too.
Yeah.
Oh, awesome. Okay, good.
Math
good.
and logic.
So there's the manual subnet calculator, and that's why I gave it to you. This is what I used to study when I had to take subnetting tests. I would recreate this before I start the test, because what this did is to just help verify and double check my answers. Make sure my math in my head was correct. Okay, so that's where we use the subnet calculator, the manual subnet calculator we created here. Subnet class A and B. This is the same when we subnet a class A or B. It's the exact same as what we just did here for a class C. All we're doing is we're just identifying how many total bits we're using, and what we need to do is figure out in the octet where the bits are turned on and off. This is where we focus on this range. Every 32 numbers is going to be different. I think we'll do an example. Yeah, let's do an example of this. So let's erase this and do an example. Sorry, what's on the board is not in the video, but one of the benefits of coming to class, huh?
Right.
That's right.
So we have a class. Let's go with class B. 172.16.0.0. Okay, let's just keep it simple with that one. First thing we do is look at the first octet that tells us what class full address it is. So it's B, which tells us what? The original.
252.255.0.
Yes, the original network mask.
Oh, okay.
255.255.0.0. Which means that the last two octets are available for me to steal bits from. So let's do this example here. Class B, so we're going to have 14 bits. Sorry, we're going to steal 8, 9, 10, 11, 12 bits. So we're going to turn all these on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means this is my new network mask. So let's just, for the sake of knowing we're going to have to type this into our workstations, let's figure out what our subnet mask is going to be.
255, 255, 240. 240.
How do we get 240?
There's 4 of them turned on in the last.
128 plus 64 plus 32 plus 16. We add all those up and we get 240. Anybody not see where I pulled that number from? Okay. So that's my subnet mask. So now what we need to do is we need to figure out the ranges. How many numbers do we have a new subnet get created? 2 to the power of 1, 2, 3, 4 equals 16. This is my range in this octet. Only in this octet is that the range. In that third octet, does that number change? So it's a range of 16. So the very first network I have is going to be 172.16.0.0 through 15. That is 16 numbers. Remember, 0 has a value. The next one is going to be 172.16.0.16 through 31. The next one, I am really slow at math, so if you know it before I do, please tell me. 42.
46.
5. 46 is down here. So you see how this is working?
You added 15.
I'm adding 16
15
to.
and 15.
You add 16 to
It
this.
should be 47.
Nope.
Yeah.
So this is 48. Yep.
There you go. You're adding 15 to each one.
48.
The other one 47.
There you go.
16.
There we go.
Hand me a pen.
And 32 counts as 1, so.
So we add 16 to this. Add 16 to this.
64. So 65, 3 and then
See if I do my math here.
80.
Okay,
So
you're
if this
working.
goes to 79. So know that in just a simple observation, these subnet ranges are always going to have the last number is always going to be an odd number.
Because you're doing with.
But now let's take a look here. How many networks are we going to be creating here? How long are we going to be writing this out? I feel like Bart Simpson.
Long time.
A long time. Look, how many networks are we creating? We have all 8 of those bits and these 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To the power of 12 gives me, somebody help with the math. What is it?
2048.
2048. I think that sounds right. So we go to the power of 8, 256, 512, 1024, 2048. I think that's right. Does anyone want to double check?
2 to the power of 12, it's 4,096.
4096.
Too much math.
Yeah, there's a lot of math.
That's what calculators are for.
So how do we do
I
this?
still have mine.
Real quick, our subnet calculator, to the power of 7 was 128, right?
Uh-huh.
To the power of 8 was 256. To the power of 9, just so we're not throwing out special or magic math here. To the power of 10, 1024. To the power of 11, 2048. To the power of 12, 4096. There we go. So we're just off by 1 there, but that's a big number, right? So we create. How many networks are we creating?
4,000.
4,096 total networks. We can only use, gosh darn it, 4,094, but we got a lot of networks. So we're creating a lot of networks. And just imagine what's going to happen here. What is going on in this third octet then? Once I get all the way to 255, what do I have to do? Then I change this to 1 and go through the same range. Change this to 2, go through the same range. You guys seeing it? That's how you get 4,096 networks.
Up to 255.
Because we're crazy.
Because you keep incrementing this and then go through those ranges that we identified. Increment it again, go through these ranges. Anybody not see that? Because I can draw it out if you want. Sometimes you really need to see it.
I was thinking you'd go to 255 on this one and throw that in there.
That's a lot of stuff.
Let's do that. Let's go to 255 through this range here. Let's do it over here. Just because I think some people need to see it, which is just fine. I'll take the time to write it out.
I'll just first blast it.
So it's 172.16.0.0 through the last octet 15, right? So let's add 16 to this. Somebody get a calculator out and get ready to throw these numbers out there for me so we double check them. Just keep adding 16 to it. So 16 through 31, so then we go 32,
48, 64.
48, 64.
128.
Wait,
80.
No, we missed one here. 80,
96.
96,
128. 144. 160. 176. 208.
192. 192.
Oh,
Sorry about that.
oh, I screwed up.
Yes.
192,
Yeah.
208.
208,
224.
224,
240.
240,
256.
we can't go to 256.
Huh.
So this last one is 255.
Okay.
This one is 239.
Yeah, I'm getting
This one is 223. You guys seeing it?
We get
Right.
that. There's
Okay,
one
you
less
get
than
that now. So let's go. So what do we do here? So this is 172.16.0.240 through 255.
And then it starts at 1.
Then we start over 172.16.1.0 through
Yeah.
15.
So then there's a whole-
172.16.1.16 through
It
31.
goes all the way up to 255
And we keep going.
at that. 255 at that one?
So this, yeah, so this goes up to 255.
Okay, right.
And then we change this number to a 2.
Holy poop.
And then to a 3. And then to a 4. You guys see it? Was it helpful to see it? Those who can see down here?
You just write out a few more, I'll get it.
Right out of
It's like, you know,
No, they're out.
172.16.32, maybe.
the last usable host in the last subnet, right,
172.
would be 172.16.255.254. Now, remember though, to this rule, if we have 4,000, where's the number? 96 total networks, we can't use the very first one because the very first one contains the original network ID. So the original rule was we cannot use the first subnet that's created, and we
First
cannot
subnet
use
at all.
the very last one because the next
Oh.
address
Yep.
is 172.16.255.255. This is the original broadcast. So that means we can't
So the whole
use
0 through 15 is unusable.
the whole 0 through 15 here, 172.16.0.0 through 15, and the 172.16.255.240
40 to 255.
network is dead.
Oh, okay.
Wait, why is it 240?
Why is?
So yeah,
Because that's part of the broadcast ID.
Let me go back to a couple slides here. So this example right here, the very first subnet, that's why it's in red, we cannot use because it contains the original network ID. And the very last, sub number 7, we can't use because it contains, the very last IP, which is the original broadcast ID. So we can't use the first and last.
Because it includes the last one.
Because it includes the original network ID of the original number that we started with, and we can't use the last because it contains the original broadcast of the original network that we started with there. Now there's an exception to that rule, and it's called Subnet 0 rule.
Oh, good.
But that's as far as I'm going to go, just saying that if you invoke the Subnet 0 command, you can use it. But the general rule is you can't. You know why they decided to do that? Because they started going, oh, we're wasting so many addresses. So then they rewrote the protocol and the standard to say, okay, we can allow it, but only if you execute the command subnet 0. Okay, so sorry to the la you guys have to listen to that, but that's what it is.
So is the last host
Just don't say
239?
it 3 times. in a
So the
row.
last usable host,
Yeah.
no, 239 would be the broadcast. 172.16.255.239 is the broadcast
That's
ID
broadcast.
from the
Subnet.
last subnet.
240, 255
So
is the last
two-
subnet, correct?
So,
Here, let's write this out in a little bit more room. We're getting scrunched here, so we can't see what's going on. Oh my gosh, that black marker is
subnet
awesome.
has a broadcast ID and a network ID.
Wow, that's nice and dark black. So let's assume that we went all the way up. Let's assume we went down, and we're come all the way back up. So we're at 172.16.255. Let's start at 208 through 223. 172.16.255.224 through 239, then 172.16.255.240
That's not
through
usable though.
255. So those are all of the subnets, right? We worked our way through that third octet all the way up to 255. Okay, this is network 4095. Remember, because we start with 0, This is subnet 0.
Right.
4095, okay. So we can't use the first, we know, because the rule says no subnet 0. We can't use this last one. So the last usable IP address in this subnetting scheme is going to be within this network. The 172.16.255.224. That is my subnet ID.
Oh, yeah.
The first usable
Fine.
is 172.16.255.225 all the way through 238, and then 172.16.255.239 is my broadcast ID.
I've got it.
So-
Dana, good? Thank you for asking that question. That was an awesome question. Wes?
Should be able to
So,
forget that
in
about
the
mine.
last, when you're subnetting, the last usable subnet, the last one in that is always going to be the broadcast then. Because that's the...
No.
I can't handle them.
Let's take this right here.
Original.
Let's take this one right here, guys. Let's take this. Let's take this network right here. This is the 172.16.0.16. This is my network ID.
Yes. 30.
So usable will be 172.16.0.15.
17.
Sorry, I gotta count up, Aaron, not down.
17 to 30.
17 through
30.
30.
The next one will be 30.
And then
33 to 47.
172.16.0.31 is equal to my
46.
broadcast
Oh,
ID.
okay, I got it.
Good
So
question. That's
each
good.
one
No.
breaks down again in each. one.
Each
one
little
breaks.
range has its own subnet ID and broadcast ID.
And then there's the negation.